registries. We've been talking about workflows, coder, mini-coder, and we've seen that most of all these tools and platforms are quite shared, and distributed over the internet. And it's really important to discuss, some of the ways in which you can share your files, persist your files, but also share and collaborate with other people overall. And I don't know whether any one of us who's sort of worked with, in one way, either written a thesis, a paper, or works, with others. We always find ourselves, in this sort of scenario, right? So, final .doc, and you take that to your supervisor or your professor, scribbles on it, writes on it, and now you have final revised .2. Yeah, it's the same file basically, and you share that again with your collaborators, supervisor. They've added comments now, so now it's revision 6 with the comments. That's a really good supervisor. And you go work on it again, and here you are. Now you're in the final revision. 8 comments are corrections.doc. Okay. And over here now, you're 9 more. You're running out of words and names to give to your file. Okay. And finally, you're somewhere here. Okay. So your file, is getting named, and I don't know, you can replace this with anything. And you're a bioinformatician, you've written a script, you've revised it. Now this one has Docker, the other one didn't have Docker. You've found a nice way from Stack Overflow, and you made changes, and now you're running into issues how you name those files. But more important is that you get in tons and tons of the same files, same duplication. So it turns out that it's not a problem that unique to us, but indeed it's a problem that that has been there, and that has been thought out by some clever people. So I think the issue of how to share files is as old as computing itself. And if you're not many people, it's easy, you can just have a copy. But when you start working collaboratively on a large project that also involves a lot more people, it becomes a little problem. So, and one way to think about it is that you can argue now, this is going to be the main file, right? And the idea is we're going to keep this file here, and if you need to make changes, you will get a copy, and then you make the changes, and then you merge them with the original or with the reference file. Okay? And therefore, if I'm here as a developer, I'm working with an old copy, okay? Then I go on to the repository and find some changes have been made. I can run into some issues. So we need a broker, someone who looks at all these changes and makes the necessary files, and sometimes also alerts other people or the other collaborators and tells them, hey, look, changes have been made. Okay? So it turns out that there are 2 ways. So you can have a central repository, a central way where you can keep files and manage them, and or you could argue, well, why don't everybody keep a copy of the original? Okay, so we're going to give everybody a copy of the original file. You will be at pleasure to just make all the changes you want, and then somehow, some way, we can bring all those files together, and we can see who's made what changes, and we have a broker again, a central coordinated way on where we can track all the changes. So the old way initially was using the non-distributed file systems, central file systems like CVS. Anyone who ever worked or are trying to access software way back in 2006, 2005, and going back, you may have had a CVS 80s, 90s, and large projects like the Linux kernel that has tons and tons of developers. It turns out that was quite a pain. So Linus Torvalds, the guy behind most of the Linux kernel, was not quite very happy, and he decided, I'm going to write a tool just to solve this one problem, because the Linux kernel is becoming big. You got tons of distributors, you got or contributors, and you need a way to ensure that you keep track of what's happening. And one way to go about it was to write something like a distributed file system. So the problem with centralized file systems is that for some reason, if the master or where the file is contained, if that server goes down or that copy is lost, you pretty much have lost all the history and all the changes that goes with that file. Whereas, what if everyone keeps a copy of the original file and has all the changes? It means that if we don't need a centralized hub, but everybody got a copy of all what's happened and the history, and you can carry that with you. And that's what Git does. So today, sort of this mid-afternoon, I've taken some actual tutorial from the carpentry, which has tons and tons of other tutorials, and I think some of the things that we've covered, which again you can go and have a look at, and some of the questions that he was asking about HPCs and how HPCs work, quite a really fancy, a really nice repository. And I like this tutorial for introduction purposes. So all the information is available CC by C, so that means we can use them. And I think on our user space, we should have, because we're all using Linux, we should have Git installed. So I'll not go very much into details about how you set it up, but this tutorial here shows how you can set up Git, which is a decentralized, distributed file system. And I think I had a quick tutorial. I was just rummaging and talking there. But to summarize what I just said, we need we need version control, right? We need to have a way to back up our files, our work, undo and refer to the old stuff. I need a way to know what changed when and what did I do. And I need a way to branch, that's maintain old releases while working on new. Okay? So, do you have a good example? Yeah. One of them is like Python, the language. So we had Python 2.7, and we had developers working on Python 3. And you still need to support the old version, because tools and tooling can depend on old versions, and they can be coupled very much together. So you need to have a way to maintain and add new changes. So some changes are very shiny, people don't need them, they don't necessarily think that's great. Old stuff is working for them. So you as a software developer, as a bioinformatician, you need to have a way to maintain that, okay, while still adding more shiny, more functional features. And you need to have a way to collaborate and work with your mates. So and keep a history of what's been happening. If I walk out of the door tomorrow and get hit by a bus, God forbid, I mean, that should not be the end of the work. That shouldn't be the end of whatever. So somebody should be able to pick up my computer and maybe pick some of the work that I've done and still continue with it. It shouldn't be the end. So good examples are like large software distribution systems like Linux. If for some reason the maintainer is not there tomorrow, or they decide to switch careers and that is no longer interesting to them, that does not mean that that tool and that software should go with the wind, or we start from scratch. And therefore, these distributed file systems and clever developers ensure that backups, references, and old code is all maintained, and people can collaborate. So, sorry, let's just repeat all the same. Yeah. So this is what I just talked about. The CVS, revision controls, and then just around here between I think like 2005, 2004, we had Subversion, which was much better than CVS, or people used to use the, quite archaic, difficult, and then Subversion came as quite a fresh thing to do, and then Git came into being, and was quite difficult to get started on early on, but that has changed in the last decade or so. So the version controls allow you to share repos. Most of them are internet, web-based, and we've seen places where we can download our tools. So, for example, SourceForge, we got things like Bitbucket, GitLab, and GitHub. Okay, all tools and terms that are very familiar with us and familiar to us. Okay, and most of these repositories take advantage of one way of version control to maintain these tools and to maintain the multiple versions of the same tool. Okay, and so I found this quite sort of a nice illustration trying to encapsulate that. You got your working directory or your workspace. You develop things and then you want to share them here. On a repository like GitHub, where other people can then hook up and get all the new updates. And you can also collaborate with other people. So Git is the main thing. It's the version control system. And then on top of Git, people build business models. People build social networks like GitHub, which I think really GitHub is a social network for largely developers and software engineers, and other communities that have emerged over there. And it's commercial. And then we got other services like GitLab, which again leverage Git as a tool. And I think Bitbucket also does Git, and I think another one that's very similar to Git called Mercurial. And I think SourceForge also does that, and I think still, I don't know whether they still persist or old file, or rather revision control systems. Yeah. So I know many of us have already either accessed or worked. Who amongst us is familiar with Git? Yeah. Most of us are. Who actively or largely works on Git? Like every new project, everything. The number just went down. Whoa. What changed? We're all familiar with the tool, but some, yeah?
We're leeching from Git.
Yeah?
We're leeching from Git.
All right, yeah. So I know that sometimes Git can become a bit difficult. So I just thought we can go through this tutorial from the software carpentries, and I thought they had sort of a nice setup. That was yeah. So essentially, I'll try to blow this a bit. You got really nice, well-curated material from this website here, and they got a story around how they are setting us here. You got Vlad, Dracula, Werewolf, and they're all working on a project together. I don't know, some planetary thing, and they use that to show how these fellows can collaborate or how they're going to work together. Sort of nice analogy. But the key thing is that once you install Git, you want to do some configuration so that the tool can know who is making what changes, and so that when you make a change and you're sharing them, they persist against a particular user or a username and an email, particularly if you also have an account on one of the software code repositories like Git and GitLab. They're going to use this to identify that stuff is coming from you. But they go a little bit more than that. You got to have all these SSH keys and ensure that stuff is coming from where it's meant to be coming, and that is consistent, right? So they go into a little bit details. I will not, and often you can also configure the tool that you want to use or the editor you want to use to make changes, and all these are supported on most Unix Linux systems: Atom, Nano, Sublime Text, Notepad, Notepad++, all different Vim for those who use them. Emacs and VS Code now, right? So it also goes into a little bit details and using Vim. How many of us use Vim or Emacs? Yeah, which one is which? Who is using Emacs? Gee, who is using Vim? Oh, looks like everyone is a Vimer here. Who uses just Nano? Yeah. And who uses Word? Oh no, you guys should ban. Not really. Yeah. So Word is not a text editor per se. It's a markup language, and you don't want to use that to persist your documents because of the proprietary markup that comes with it. So often what we're dealing with most of the bioinformatics is just plain text files, right? But Git can store and keep Word documents for you as well. So this tutorial goes in, but I will not start from there. So I'm just going to go to the next one. So creating the poster. So this is sort of the characters in this tutorial. We may be familiar with some of them, and they're going to use that. It doesn't matter for me. I think I'm just going to home into the commands. So the first command here, well, it says and we can use that. Let me just confirm. Do we all have Git? You can confirm just by running Git on the terminal. I would assume that it's already installed. It should be installed. Yeah, just to confirm. So you can maybe create a directory. So you don't have to go to the desktop. You can just create a directory called planets. We're just going to walk through here. And then you can change your directory to planets, right? So I'm just going to do something similar here. Blow this a bit. Oh. So on my top level here, I have my planets dir, so I'm just going to cd to it. And you can do the same. So often we start on a new project, we create a directory, and we're going to persist our files in this directory. And therefore, we need a way to tell Git to start tracking our files, okay? And to start tracking our revisions, okay? So the way we do it is to initialize what you call a Git repository by running git init, and if you do that, it will initialize it in the current directory. So the dot there says our current directory. Okay. So there are a couple of things I've not set up. That's why my environment is screaming, giving me some hints, right? Which we would have done in the, the earlier step, yeah. But the most important, I think, is it's telling me that it has initialized an empty Git repository. Okay, good. Okay. We all been able to, yes, Davis?
I've not been able to get that master
Oh, so sorry, don't worry about it. I've decorated my terminal a bit. So
Okay, hopefully these batches will last. Thanks, John.
yeah, right. So the way I think I like also to think about Git is it's very interactive, just similar to the tools that we've worked with before, and you can always check the status of your project by running Git Status. And I do that quite a lot. Again, it's telling us that we are on a branch main, no commits yet, and there's nothing to commit, create copy files. So it's giving us sort of a hint on what we should do to start tracking files. Okay. So here there's a small exercise again here. There's a little bit of the what the story is about with Dracula here wanting to keep track of information about moons. We were in the planets, and despite Uffman concerned, Dracula creates a moons project inside his planets project with the following sequence of commands. So again, this is where we were. CD, we are still within the planets directory, and what Dracula is doing here is that he does this, make dir moons, and then he goes to moons, right? And he does a git init in there. Okay. And now there's a question. So I'm just going to do something here. Just to you might not have the LL command, but yeah. So I'm just I've created that. I've run the commands down here, and I've moved back up here, sort of to get the gist of the story. Okay, so Dracula wants to keep track of everything, so he goes on create a moons directory. So he wanted to track planets, creates a moon directory within the planets directory. He moves into that directory, and he initializes a new Git repository there. Okay, and you can confirm by doing ls -a. So the question is the git init command runs inside the moons subdirectory required for tracking files stored in the moon